Hi, this is Empowering Introductory Algebra, the series created to assist students to overcome any basic algebra deficiencies and build a strong foundation leading to college-level studies. Hi, I'm Bob Young, Assistant Professor of Mathematics at Brevard Community College. With the help of the WBCC crew, we will bring you introductory algebra lessons like no other. Let's pick up where we left off, and we'll show you why. Now remember, in our last episode we were discussing rational expressions here. We were simplifying rational expressions, which are polynomial fractions. We were adding and subtracting them. And we want to go back to the graphic here because we're going to close on subtraction. And remember the 4 steps here for addition and subtraction of rational expressions. And the most important step 1, whenever you add or subtract fractions, whether they be variable or numerical, get that LCD, the least common denominator. Remember, and if you can win that battle, you're in there. And that's going to carry over to our lesson today, as a matter of fact. So in order to get that crucial LCD, factor the denominators if necessary, and break all numbers into prime factors. Multiply each number the greatest number of times that it appears in any one factorization. 2, make equal fractions with that common denominator. 3, add or subtract depending on the problem, put it over the common denominator. And step 4, always look to reduce. So if you missed these in the last episode, make sure you get these notes down, and we will go to the last example here. And some of you might be saying at this point, when we go to this example, the last one for subtraction, boy, these problems are getting more difficult, Young, and things are getting tough, and it's not as easy as it was in the earlier episodes. But remember, we're preparing you for those college-level courses, so we want to get you up to par. All right, so when we look at this one, we've got a subtraction fraction problem. And remember, I said that minus sign is dangerous, so you can take it and either put it through the top or bottom. Now, we really only put it through the bottom when these two are opposites. And obviously, these aren't opposites here. Most of the time, 99%, I like to take it and run it through the top. So I'm going to make that a plus -2. So I'm going to put this sign on the 2 where I won't lose it. All right, then I'm going to factor the denominator. So we have 2 trinomials here. So when we factor these, j squared plus 5j plus 6, the factors of 6 that will add to give me 5 in the middle is going to be j plus 3 times j plus 2. And of course, you could FOIL this and check it from previous lessons. The second trinomial, these aren't too bad of ones to factor. j, factors of 2, the outside that will add to give me 3, not a lot of choices here, plus 2, plus 1. All right, so now that we've got these denominators factored, we can come down here and set up the shell, the LCD, the all-important LCD. So what you do to get it, which one has the most j plus 1s in it? This one has 1. So that's part of the denominator. Which one has the most j plus 2s? Well, each one has a j plus 2, but the most in any one, 1. And which other one do we need? A j plus 3. So never let it be said out there that Young doesn't have a sense of humor. Check the LCD out, j plus 1, j plus 2, j plus 3. So let's go ahead and set that up here on the other side. Now we need to make equal fractions out of what we started with this common denominator, step 2. See, so once you get everything in order here, you can look at this one and say, gee, which one is this one missing, Young, to become the one with the common denominator? Well, it's missing the j plus 1. So we'll go ahead and multiply both top and bottom by the j plus 1, because remember, whatever you do to the bottom, you must do to the top. Now what do I have up here in the numerator? Well, some distribution. So when I multiply the j through, that's what's going to go here. So j times j distributing, j squared, j times 1 plus j. All right. Second fraction. Here's the common denominator we established. This one, the second fraction, is missing the what, Young? Well, it's missing the, j plus 3. And again, whatever you do to the bottom, you gots to do to the top. All right, so we're going to distribute that -2 through and get -2j minus 6. So watch those signs there. Now we can do, if you remember in previous episodes, the CLT bird. All right, the bird that flies and collects those like terms and puts these two fractions into one. All right, so let me go ahead here. Notice, boy, these are getting complicated as we get deeper into our understanding of algebra. It just gets better and better. All right, so adding and collecting the like terms in the top, there's only this 1j squared, so we'll go ahead and bring him down. 1j and a negative 2j gives us a minus 1j, and then we've got the minus 6. So that's the answer, right, Young? Well, I don't know. This fraction may reduce because I'm sensing something may factor in the top here. Let's try to factor this top. Are there factors of 6 that will give me a negative 1 in the middle? I think so. And I think when we factor this, we're going to get jj minus 3 plus 2 all over our common denominator. So you always have to remember step 4 when it comes to fractions. It doesn't matter if they're ones with variables or ones with numbers. You always have to look to reduce. So now notice we've got the j plus 2 over the j plus 2. Anything divided by itself reduces to 1. And we've got the chop going there. We can chop those j plus 2's out. All right. And then that's the final answer. J minus 3 all over j plus 1 times j plus 3. Now, why can't you chop the j minus 3 and the j plus 3? They are not opposites, and they are not the same creature. Hands off. If you try to chop these, you'll hurt your hand. You'll go, achoo! You ever see one of those guys try to chop one of those cinder blocks and not make it, and they'll go, oh, their hand will be like that. Your grade will be like that if you try to chop where you don't have to chop. All right, let's go to the graphics here. Next thing we're going to talk about, next topic for discussion as we continue our rational expressions and equations now. We're going to equations, solving rational equations. Now, what's equations have in them? Equal signs. So, one, when two fractions are equal, remember, if you just have plain old two fractions, if a over b equals c over d, then you can cross multiply and set the cross products equal. So in other words, a times d will equal b times c. And in step 2, now what if you have more than just two fractions equal, Young? Well, remember, we've discussed this in previous episodes. To get rid and clear fractions in equations, remember, you can always multiply by, oh my gracious, look, there's that thing again, the LCD of both sides of the equation to clear all fractions. So boy, that common denominator, the least common denominator, crucial here. And step 3, now we haven't done this in previous sections and chapters. Check and make sure in step 3 that once you get that answer, when you plug it back in, it doesn't cause any denominator to equal 0. And remember, we talked about a denominator equal 0 when it's in fractional form. It's undefined, so it can't happen. So be careful on that. So let's go to some examples here, solving rational equations. And notice I've got a little one here, solve for x. 1/6 plus 1/8 equals 1 over x. Now, since there's more than two fractions here, I want to go ahead and find the least common denominator of 6 and 8 and x. And what would that be? Well, I think it would be 24x. Okay, so what we want to do is multiply everything in the equation through by 24x, and what that's going to do, if you see that common denominator, it's going to clear all those fractions out of there. And remember, with equations, Young used these two letters, BS. All right, and you know that if you've been watching this series, there's plenty of that in some of these episodes, but BS, when it comes to equations, means both sides. Whatever you do to one side of an equal thing, you must do to both sides to keep them the same. All right, so now we're going to distribute that 24x through. So let's just go ahead here. Take 24x over 1 times the 1/6. Write it out. I get a lot of students that just try to do these in their head and they get in trouble. Plus, we're going to take the 24x over 1. Now, you know why I'm putting this over 1 when I multiply it through? Because then I can see the chop chop or cross cancel better. All right, equals 1 over x times 24x over 1. So I'm taking each term and making sure I hit it with the 24x. And if you want to, you can even color code these, see, so we're getting them underneath each thing there. All right, so cross-canceling now, 6 goes into 24, 6 goes into 6 once, into 24 4 times, and we end up with 4x times 1, 4x. Plus 8 goes into 24 3 times, 8 goes into itself once, into 24 3 times, and we left with 3x times 1, or 3x, equals over here what chops out? Well, the x in the bottom with the x in the top, anything divided by itself equals 1, and we're left with 24. So multiplying through by that LCD wiped out the fractions. Life is good. So now we can collect like terms. 4x plus 3x is 7x, equals our number 24. And good equational practice here to solve for x. What takes out multiplication? You remember, divide both sides by 7. So the final answer would be x equals 24/7. Okay, let's do some more. Solve for y. All right, so here we have y plus 4 over y equals -5. Now, what could be the common denominator? Well, I kind of like this one because not only is it the common denominator, well, it's the only denominator. So we're going to go ahead and multiply everything through by the common denominator y. All right, so let me go ahead and write that out. Distributing, we're going to have y times y plus y over 1 times 4 over y. Now, why did I make this one a fraction when I multiplied and I didn't make this one one? Well, this one wasn't a fraction. This one was. So I can see the cross cancellation better here. Equals the -5 times y over here. Don't forget what you do to one side of equal things. BS, both sides. All right, so now when we multiply y times y, there's good old power rule number 1. Whenever you multiply same bases, you add the exponents. 1 plus 1, you get y squared. Plus, the y's chop out, and you're left with plus what? 4 equals -5y. Now, the reason I picked this example is, notice this one has a y square in it when the previous example just had all plain old the same variables. What does that y square tell you from past lessons? That tells me that we're going to end up with possibly more than one answer. And to get that one answer, remember, you have to use the zero product principle. You have to get everything equal to 0. So I'm going to bring that -5y and put it over to the left by adding 5y to both sides. So what that leaves us with is y squared plus 5y plus 4 equals 0. Now, how do we get our two answers to this, Young? We've got it in that factoring form here. We can factor the y squared plus 5y plus 4 into y plus factors of 4, the outside terms that will add to give you the middle would be 1, 4, or 4, 1 equals 0. You could check that by foiling, get this back. So my two answers, what makes the first parenthesis 0? Remember, so what comes around in algebra goes around. What did I tell y'all? It always comes back. And what makes this one 0? My two answers, y equals -1, or the second one, what makes it 0? Y equals a -4 would make that 0. So remember, when you multiply, if one's 0, it's all 0, the zero product principle. Now again, something we haven't discussed in a while with equations, if you take the numbers and plug them back in up here, they'll make perfect sense. You always have to guard, make sure this number doesn't make the denominator 0, neither of these will. Let's go ahead and check -1. I'm going to go back up here, and wherever I see a y, I'm going to put in -1. So y, -1, plus 4 over y would be plus 4 over -1 equals -5. Let's see if this makes sense. Equals -5. Now remember, 4 divided by -1 is what? -4. So we end up with certainly a true statement that makes sense, don't we? We end up with -1 plus -4 is -5. So when we plug that -1 in here for y, it checks. And that's the nice thing about equations. And then you can feel that way on the test. Yeah. And also, if you tried -4 and plugged it in there, it would check as well. So I'll let you guys try that one out there. All right. Moving right along. Now, in this example, notice we only have two fractions equal multiplied together. So let's go back to that graphic one more time here. And notice in step 1 there, when two fractions are equal, we can just take the cross products and multiply and set them equal. All right, when you just have A over B equals C over D. And the other ones we had more than one thing to deal with, so let's go back and look at this case. Let's go back to the examples here and we'll show you why step 1 works here. Now, we'll go ahead and take and cross multiply here, C plus 5 times C plus 4, and we'll set that equal to C minus 2 times C minus 2. All right, so if we want to solve this equation for C, we'll take the cross products. Now remember why that works with numbers. If I gave you all the fraction out there, 3/6, you would tell me it reduces to what? Well, you'd tell me it reduces to 1/2, wouldn't you? But notice the cross products, 3 times 2 will equal 6 times 1. All right, so that's why it works. And even if you multiplied both sides by the common denominator, it would be C minus 2 over C plus 4. If you wanted to do that on each side, you would still get to here. So it works both ways. I mean, you know, if you just have two fractions like this. Now, what do we do when we multiply binomials? It's the old FOIL thing. Okay, first outside, inside, last. So again, what comes around goes around. This repetition's good. It'll make you strong. All right, so when we FOIL, C times C, first two terms, C squared. The outside two terms is 4C. The inside two terms is 5C, so we end up with plus 9C. The last two terms, plus 20. Okay, so that's FOILing these two together. Over here, we're going to FOIL, we'll get C times C, first two terms, C squared. The outside and the inside are both going to be the same here. It's going to be minus 2C. Minus 2C gives us a minus 4C. Negative times negative, last two terms, watch your sign, plus 4. All right. Now, some of you might be looking at this and saying, Young, there's the squares. We're going to get two answers to this one, but watch out. Because when we subtract a C square from both sides, if we want to go left or right, it doesn't matter. When we subtract a C square, what happens to them? Toodles. Bye-bye. They go out. So those will go out. Anytime you have opposite things that are equal on opposite sides of the equal sign, they're just going to go out. So what we're left with is now a one-answer creature. All right, so 9C plus 20 equals negative 4C plus 4. We'll go ahead and bring the letters to the left by adding 4C to both sides. And we'll take the numbers to the right by subtracting 20 from both sides. So y'all remember the old LLNR, letters left, numbers right, to get answer when there's only one variable involved. So 9C plus 4C is 13C. Equals 4 minus 20 would be a negative 16. Now, does that scare you? This isn't going to come out nice and even? Well, it shouldn't, because you know as we get deeper, these are getting harder. You're going to get stronger doing them. Divide both sides by 13, and you will get the final answer, C, equals negative 16 over 13. So, boy, taking that and plugging it in here would be a monster to check, wouldn't it, to see if it works? But I assure you it will. Okie dokie. And one last example here on solving rational equations. And you remember, on this network, BCC, we don't just give you the easy ones, we give you the toughest ones here as well. All right, solving this one here now, it looks like something factors in one of these denominators. The old difference of two perfect squares is back for a visit. So this will factor, if we're trying to solve for A, into A plus 3 times A minus 3. So looking across here, the common denominator would be 1A plus 3, 1A minus 3 would be the most. So we're going to go ahead and multiply this gargantuan beast through by A plus 3 times A minus 3. That's what gets run through that takes those fractions out. Now, again, there's a beware here. Beware, no answer makes one of these denominators what? 0. And I think in this case, something's tingling here in me. I don't know. Yeah, there's been a lot of lightning this summer. We'll have to see. All right, so distributing here, we're going to take A plus 3 times A minus 3, put it over 1, times the first one here, 1 over A plus 3. So I'm taking that, multiplying it by the first term. Signs don't change, plus A plus 3, A minus 3 over 1 times the second one, equals, if I write this one out here, I'm going to try to sneak this in or I'll run out of paper. I'm going to put the a plus 3 times a minus 3 over here, if it's all right with y'all out there, and put it over 1. When I multiply it through by this, and we'll see what happens here in a second. So when I multiply the common denominator by the first fraction, guess what's going to chop out? You guessed it, and I'll do it in a nice pretty orange here. The a plus 3's go out, and we are left with 1 times a minus